Good afternoon. My name is Matt Johnson. I'm an application engineer with Allied PLM Solutions. We want to welcome you and thank you for joining us today for this session of LunchBytes. Allied PLM hosts LunchBytes once a month to explore the capabilities, features, and functionality within the different Siemens PLM software products that we service. To maximize the value of your time during these half-hour sessions, we want to focus on specific topics or workflows. And we will welcome your suggestions for any topics you'd like to discuss in the future. Today we're going to look at maximizing the benefits of synchronous technology in the assembly environment. By now, most solid edge users have a good understanding of what synchronous modeling is regarding the part environment. So today we'd like to build on that and show you how we can fully maximize the synchronous workflow by expanding its use into the assembly environment. Synchronous is not just a part modeling tool, but builds upon it. So let's look at maximizing your benefits in your day-to-day design approach by utilizing synchronous technology in the assembly. To avoid audio feedback and other distractions that come along with hosting a teleconference, we've placed all of you in a listen-only mode today, but we'd really like to encourage your feedback, so we're going to ask you to email us any questions, comments, or follow-up from today's session, and we'll get back with you just as quickly as possible. And like we mentioned, we'd love to hear your feedback, suggestions for future LunchBytes. So let's go ahead and get started. I got a few screenshots here of some models that we're going to use for demonstration purposes. We're going to skip a lot of the PowerPoint today and just jump right into Solid Edge. Some of you have been with us recently at some What's New in ST6 events or Solid Edge summits and have seen some of these example models before, but I'd encourage you to stick with us as we go through and compile all this information today. It's kind of your one-stop shop for future reference of synchronous assembly design. So some of these examples or demonstrations you may have seen one-off, but as we build these concepts together across multiple models, I hope that the bigger picture of synchronous assembly design becomes more clear to you. For the sake of our agenda today, we're going to cover about 25 minutes of material. And we're going to look at, what are our basic part editing tools and how do we do that in the assembly environment. So if you've mastered or began using synchronous approach at the part level, how do we build on that in the assembly level? And to do that, we need to understand there's different selection priority modes, face and part priority, which most of us are familiar with by now, but how can we maximize the use of those while we're designing? And we're also going to talk about dynamic edit that's been added and enhanced in ST6 to give us some additional functionality over ordered parts as well. We're going to talk about live rules and go into that in pretty much detail. And we're going to talk about the use of Selection Manager to help us get the select sets that we need to edit features while we're in the assembly level. We're going to talk about the steering wheel not just as a tool to move components randomly, but to move them specifically from an origin point to a destination point. And also, how do we use the steering wheel to build in design intent where we're making edits at the assembly level. We'll look at some enhanced functionality in ST6 that allows us to place PMIs at the part model, and this allows us to, again, stay at the assembly, focus on design intent, and make edits at the part level. And then, as time allows, we'll look at some additional features in ST6 at the assembly level that greatly enhance part level design. So with that, I'm going to jump right into Solid Edge, and we'll get started. So this is a model that's been imported from a non-native Solid Edge format. It's important to note because as you look through it, you might see some geometry errors or whatnot, but that's not relevant to really what we're looking at today. But I just wanted to point that out if anything jumps out, that for what we're going to show today, the model works very well. And we're going to in-place activate into this sub-assembly. And since we're talking about maximizing your use of the assembly, let me point out that one of the quick keys I use very much at the assembly environment is Control Q. So if I hit Control Q on the keyboard, you'll note that the previous level is either hidden or shown. Now that's the same command as going to View and Show Hide Previous Level, but very often when in-place activated either into a part or a sub-assembly, I need to toggle the state or desire to toggle the display state of that. So I'm going to turn that off now because it's not needed. And what we're going to focus on really is just how do we make part level manipulations. I want to change these colors to black edges so that the parts are more visible for us. So in the assembly environment, our default selection is what we call part priority, which is the way that we've always known it, that when we hover our mouse over a component, that component as a part is what's selected or highlighted. But if we've built our parts as synchronous parts, we'd like to be able to make synchronous edits on those parts at the assembly level. So on our Home tab, under our Select tool, we've got a number of options that we're going to explore today. And the first is the difference between face priority and part priority. And that becomes fundamental when we work with synchronous components at the assembly level. We'll also look at the add and remove modes, and then selection manager. And then just also be aware of this icon here, and as I zoom out and hover over it, we'll see that this is our component select and move tool. That is, in essence, the assembly steering wheel. So as I select a component, I get the assembly steering wheel. Some people have turned that off because they don't want their assemblies to look synchronous-like. Note that now when I select components, I do not get the steering wheel. I do not get to take advantage of the synchronous assembly workflow. So make sure that you have the Enable Component Select and Move tool enabled, turned on. It should have a little orange highlighting to it. And now as I go back and reselect components, you'll see that I do get the steering wheel. And that is what we desire. I'd also encourage you to hover over the Select tool and read the quick tips. And it tells you that Control Spacebar and Shift Spacebar are some common workflows to change our selector. So you'll note that right now the icon of my selector is in part priority mode. The glyph next to my arrow actually has a little icon that is very much the same as the icon in our Pathfinder. It emulates a part. I can come to the Select tool and go to face priority, and now I get a more planar type icon on my cursor glyph. I can toggle that back and forth, or Control Spacebar is going to toggle that for me. So in part priority mode, when I select the part, I select the entire part. But in face priority mode, if it's a synchronous part, I get to select the faces of that synchronous model. So for this design approach, we ordered this bearing block, and we downloaded the model off the web, but when it came in, it was actually 30 millimeters wider between the slots. So all we really need to do is modify this face by 30 millimeters. So I can simply select that face, and since it's a synchronous part, I'm making a synchronous edit at the assembly level. So if I were to extend this by 15 millimeters, I would expand my overall width by 30, which is the design intent. But I don't want to have to do this to multiple parts at the same time. So what we need to do is understand that not only can we select a single component, but if we select another component, you'll notice that my select set is toggling between them. I want to select them both at once. I can hit space bar, and now I get add remove mode. I can hit space bar again to get add only or remove only. In this case, I want add remove. And now I've been able to add the other face to my select set. And note that live rules is honoring any relationship in either of the parts that should come along for this ride. In this case, this back face of coplanar relationship, I don't want to honor that. I don't want that to come along. So we can go to live rules and deselect coplanar relationships, or I'd encourage you to get used to the quick keyboard shortcuts. So here our tip tells us that P toggles on coplanar relationships. So by hitting P on my keyboard, you'll see that I'm either honoring or not honoring the coplanar relationship. So now I can modify two parts at once, honoring what I would consider design intent, that if the bearing gets wider, that the bearing block support needs to get wider. And instead of modifying two parts individually, I can modify them at once. But more so, the slot is what really changed on this part. And as I select it with synchronous, what I'm selecting are faces. And what I want to select is the slot as a feature. So I'm going to go Shift Spacebar, which puts me in Selection Manager mode. You can access that from the Select tool by going to Selection Manager, but you'll see the little plus box by my icon. Now as I select a face, Selection Manager exposes itself, and I can certainly pick this as a tangent chain, but it's often a lot easier just to recognize this as a feature. So I want to recognize this slot, and I can hit Spacebar to get out of the Selection Manager mode, and I'm still in the Add Remove. So I do need these exterior faces to go along for the ride. And then in the block, the support block, there's also a mounting hole. Now I have a select set of everything I intend to move. And I'm going to move the origin of my steering wheel because it's something we're going to talk about later. When you're making a delta move, meaning all I care about is the distance of the move, it doesn't really matter what my origin or my destination point is. But there are times that we do care about this. Now we need to understand live rules a little bit more. The one thing that's moving is the chamfer on this bearing block, and I don't want that. And that appears to be a concentric relationship. So as I toggle off concentric, you'll see that my slot's moving, but now that relief in the bearing block's not coming along for the ride. And the last one I'm going to turn off just by hitting A quickly on the keyboard is coplanar by axis. I don't want those holes in the back to come along. So being mindful that the steering wheel is kind of placed out here in space, I'm really just making a delta move. I'm going to move this by 15 millimeters, and by default that gives me 30 on my overall width, which was the design change that we really wanted to make. So instead of having to go to two parts individually and change multiple features, I'd have had to change the block width and the slot location. I'd have had to change the block width and the hole location. We can make all those changes in the synchronous assembly, and it actually allows us to honor design intent a lot quicker and a lot more robustly and accurately. So I'm still in face priority mode. I'm going to toggle back to part and get my multiple select, and I'm going to delete some of these blocks because when we imported this geometry, so we just grounded it. We made no relationships. I'm going to quickly run assembly relationship between these two select sets. I'm going to say find all the mate and the axial lines. And so if we look at this now, you'll see that we turned off or deleted the ground relationship, and now we have a fully constrained block here. I still have my steering wheel, and it's very important now that when I orient it, I need to orientate it to a known key point. This isn't going to be a delta move. This is going to be a very specific move. And I want to move this block from this mounting hole location to this mounting hole location. When I've done that, I've also got the options turned on right now to heal my assembly relationships. So note that I moved the block, but the relationships have healed themselves to the new location. So moving that block from the known key point is very important in this instance. And while I'm moving, Solid Edge says pick the components you'd like to build relationships to. Well, I'd like to heal these relationships back to this purple base block, and I'm going to say OK. If we do this again and we look at the options, there's some options here that says what do you want me to do with the relationships that I have in the assembly. You can leave them as they are and not heal them. You can repair them, which basically extends mates instead of create new mates. Or we can remove the external relationships and add new ones as they're possible. So this time, instead of moving this block, I'm going to hold down the control key and I'm going to copy this block. But what's important again is that I know where my starting point is. So I'm going to put my steering wheel at a very known key point, hold down control and make the move. And now as I bring this back to this key point, I'm going to repair this relationship. Since this is in my select set, I'm going to go ahead and hit space bar to add the original block to it. My steering wheel is already positioned in a new point. I'm sorry, in a known point. So I'm going to hold down the control key. I'm going to drag off another copy and go to this key point. Prompt bar tells me to pick the part I'm making relationships to. So now quickly, I've created 4 instances of this guide block, and they're all constrained in the assembly by using the assembly component move tool, move and copy tool. So that's kind of the fundamental approach of how we use synchronous in the assembly environment. But I want to show you this motorcycle, which we use as a demo sometimes, and show you more specifically how this benefits us during our standard design approach. I've removed some components here in a configuration to make this a little easier to see. And what we have is a kinematic functioning assembly. And this is an adjustable gas spring. As I move this thing, we're going to reach a spot where there's going to be some interference. And I'm not going to run detection analysis right now, but you can see that I've collided here, and I need to make an adjustment to this part. This, in my opinion, is where synchronous design approach really pays off in spades. I can do part priority in place activate and make changes to the part, but I want to do a face priority and select the boss here, and I'm going to move the steering wheel just so we can see it, because again, this is going to be a delta move. It's not a known key point from to. And I'm going to begin to move this face of the part, but as I move the part, the kinematic relationships of the assembly are being honored as well. So now I can see what is happening not only to the part, but what happens kinematically in the assembly. Now, we don't have to just drag things in Synchronous. We can also use dimensions. So I'm going to drive this thing by the dimension, and I can use my mouse wheel and do a dynamic edit, or I can say that, hey, I know the maximum amount of material I have per my stock is going to be 85 millimeters between those holes. And so we can look at what that did kinematically to the assembly, and did it clear up any type of interference we have. So we still have a kinematic functioning assembly here, but we were able to modify the part at the assembly level and see what impact it had to the kinematic function of the assembly. Positioning the steering wheel is key to all synchronous edits, both of the part and the assembly. What we have here is a part that had uniform bosses on 3 of its sides. There's a 3 millimeter offset built in between this face and the back face of this here, and we want to honor that same 3 millimeter offset on this boss, but it needs to get larger. I'm going to select that face, and if I begin to make the move now, symmetry is being honored, which is what I want. But if I bring this all the way out to this key point, I don't infer that same 3 millimeter gap as the other lobes on this tri-lobe part have. So what I want to do here is select this face, and before I make my edit, I want to transition, or translate, I guess I should say, the origin of my steering wheel. So by holding the Shift key, I'm actually able to move the origin point of my steering wheel. And I'm going to enter 3 millimeters in here and enter that. So now the origin of my steering wheel is offset from the face by 3 millimeters. And now when I begin to make this edit and then pick up on this key point, you see that I made a part level edit at the assembly, but I honored the design intent that said, hey, I'll need 3 millimeters equally on both sides of this part. So here we are doing part level design at the assembly without needing to stop our workflow, go in place activate, make an edit to the part, come back, close and return, and see what happened to our assembly. We're able to make those edits on the fly by honoring our part priority, our face priority, and you'll see that we can make modifications here. And not only do we get to modify the part, we get to see real time the kinematic relationships that are being updated in our assembly. I think that's the benefit of Synchronous that's very oftentimes under-discussed, is we often think that Synchronous is a part-level tool, and we need to be thinking of it as a design tool. And how do we use it to help us in our design approach? I'm in a part priority mode right now, so when I select these parts and in place activate, I want to point out that this cover here is an ordered part, and the component here is also an ordered part. So in ST5, we had some new functionality that allowed us to edit the profile if we were using face priority. So I'm going to toggle to face priority, and you'll note that I'm not selecting faces on this part because it's an ordered part, but I'm selecting features. Note that if I select these faces, these are true synchronous faces. They're not feature sets. But over here, we're selecting an entire set of faces that make up a feature. So now I can either edit the profile, which is going to take me in place activated, and there's a couple steps involved there, or I can just dynamically edit this feature right from the assembly. And this is new in ST6, but now I can modify the diameter of the part or the overall length of the part, and this is an ordered part, and we're making edits to it at the assembly level. This is something new. We have to be in face priority mode, and when we select ordered faces, we will infer their feature set, and we're going to expose the dimensions that are given to those, and then we can make modifications. The same is true on this side where this rib and pattern is. If I select this face, the face actually exposes the feature, and then I can expose the dimensions to that, and I can modify this rib pattern feature of an ordered part by using synchronous assembly modeling. So I don't have to bounce back and forth between modes. I simply need to work with where I need to work with when I need to be doing that part of my design. Let's bounce back to the top level assembly here, and I'm going to open up two other components that we can look at real quick that are going to show us some additional functionalities. So when we're in the assembly environment, we want to limit the amount of actions we need to take that take us down into the part level. And so if we want to modify this part, I know that I can go to face priority and I can select this face and I can make an edit to it. But if I want to dimensionally edit this part right now, I don't have the ability to do so. I need to in place activate and then place a dimension. If I were to try to place a PMI dimension here right now, we'll see that what we get is a reference dimension, and we know that because it's purple. Purple tells us that it is 140, but you don't have the authority to change this dimension from here. So let's delete that, and let's replace the dimension. And you'll note that new in ST6 is the ability to place a PMI dimension that drives down into the part model. I'm going to place the exact same dimension. You'll note that as soon as I place a dimension on the part now, Solid Edge is going to expose any PMI that's already in the part to make sure I'm not over-dimensioning. So now I can place a dimension here, and I don't just drive the face, but I can drive this internal gap with a dimension. And so now if I were to come back and pick this inside face, again, look, the dimension is exposed. I'm able to make the modification of the faces from the assembly without ever stopping my assembly design approach and going in place, activating to a part. So let's do the same thing here. I want to modify this sheet metal component that fits inside here, and I think I set that at 190, so let's just set this guy to 185. And you'll see that we're able to make these part level edits at the assembly and really streamline our thought process and our design approach. And as long as we're in face priority, whenever we select that, we will be re-exposed with the PMI. As I select this face, we'll see the PMI that already exists to it, and we can make modifications to it. And then let's use assembly features. And I'm not going to spend a lot of time here, but just note that in ST6 we can now create synchronous assembly features instead of ordered assembly features. And I'm going to place these two circles here. They're actually holes. And I'm going to punch them through everything. And I didn't dimension those, and that's because, you know, I can do that now at my assembly environment. So I'm going to come back up in here and say I need a PMI between these holes, and these guys should be 20 millimeters. And since I'm still in the command and the option is still set, I want to actually drive these from the outside edge in 35 millimeters. So we can do all this part level design intent at the assembly level, place in assembly features at the part level, and modify our part. So if I go to part priority, I'm simply getting the parts here. But the beauty of having face priority selection is that any face we select that has dimensions associated with it, we're going to be exposed those dimensions via the PMI from the assembly environment. So lastly, let's look at some enhancements to assembly features that I think a lot of you will find very helpful. And one of those is the addition of the subtraction to our assembly feature set. So in part priority, note that my mounting plate here has no features to it right now, and I'd like to actually add the counter bore that this motor needs. So I'm going to say create the assembly feature, and I want to make this a synchronous feature if possible. In this base plate, I want to remove all of this material. And so now as we in place activate this, you'll see that we actually subtracted all that material. Now this is really just a subtraction line to line. We can build on that by recognizing the holes. You know, we can come in here and convert these to threaded holes because they are threaded. And this one here, we might just want to add just a little bit of tolerance to each of the holes. So I don't have to design these holes. I'm just going to recognize what they are and make the modifications. But what we don't have here is any associativity. So as I move the motor, note that the hole underneath it doesn't move. This is the benefit and the beauty of synchronous editing. It's not just about a single part. It's how do how do we work with the edits between multiple parts? So let's hide these screws real quick so they don't confuse what we're looking at here. And then I want to move this motor housing, but there's no associativity between it and the large counter board. So what I'm going to do is make sure that in my select set, when I make this move, I actually select the motor housing, and I need to add remove to my select set. And I'm going to go to face priority, and I want to select that large hole in the bottom. So now that's in my select set. So now as I make this edit, you'll see that we can move the part, and I need to turn off lock to base plane because we're locked right on that base plane. As we make that synchronous edit, the feature will move and the mating part will move. And I've moved this with my spacebar accidentally, so you'll see that I actually moved that just a little bit. Let me show you one other approach we can do. And I did an undo command here that has done something we haven't been able to do in the past. When we undo, we can actually undo all of our assembly design as well. So within the part environment, so I no longer have features here. And let me show you quickly to end this that we can actually maintain the links in the feature should we choose to. So now I'm going to add all this as the tool body. Now if we go to the part, you're going to see something very familiar to you. We got all these inner part copies. Solid Edge did the work for us here. It said, hey, if I'm going to do inner part copies because I'm associative, and then I'm going to do the subtraction. Okay, I'm going to delete those so we understand what we're looking at here, and I'm going to toggle back on with Control Q. I am in place activated into this part. New in ST6 is also the ability to use our surfacing tool of replace face. We can replace the face of a part to the other faces in the assembly. So if I go into synchronous mode now and under surfacing I say replace face, I want to replace that face with this face. So I'm not just within a single part anymore, I'm actually anything within my assembly, which is very powerful if you have something like these the fittings on the front here and you want to make sure that this face never goes inside those fittings to create some sort of manual stop for you. And we can also now use the assembly reference parts for reference planes. So if I go to my sketching tool and I say I want to create a rectangle, I need to pick a plane. By holding the shift key now, I can now pick the faces of my assembly parts. So if I need to build a fitting, that's right here, I can actually draw that and I'm in my part. So when I Control Q to toggle off my assembly, hide previous level, I now only see the plane relative to the part that I'm working at. So a lot of concepts we talked about real quick. We'll go back to our PowerPoint and just say that here were a couple of the examples, and as we look at the agenda, we talked about each of those things and how we can maximize assembly design by using synchronous part editing features. A replay of this LunchByte will be available on our website, www.liplm.com. We encourage you to take a look at that, not only today's LunchByte, but all of our LunchBytes. And while you're there, I'd also encourage you to take a look at our current promos for training. If you sign up for training now through the end of the year, you can actually get an iPad mini or a Google Platter. So we appreciate your time today. We do encourage feedback and comments via email, and we'd love to hear your suggestions for any topics you'd like to hear for future LunchBytes. Thanks for joining us today, and we'll see you next time.